Hello everyone and welcome to the NPTEL course in Pharmacognosy and Phytochemistry. In this week we are learning about potent compounds called as alkaloids, which are alkali-like nitrogen containing. In the previous sessions we saw what are alkaloids, we saw the different classes of alkaloids, and we've learned a few examples of alkaloids. To recall, we've learned tropane alkaloids. From belladonna we have learned different alkaloids such as opium. Now in this session we learn three more examples of alkaloid containing drugs, which are cinchona, which contains quinine, ephedra, which contains ephedrine, and vasaka, or commonly referred to as adulsa, which contains the alkaloid vaseline. Let's start with the cinchona. Now cinchona has a very interesting story. Cinchona is a drug which has been discovered in as early as 15th century. This has been used for its anthelmintic as well as antipyretic effects. It's also called as Cortex cinchonae or Peruvian bark from natively where it occurs, or Jesuit barks, which were the set of people who actually used the bark for their medicinal purposes. Now the name cinchona comes from the Countess of Cinchon, who was cured by consuming this bark, the decoction of this bark, and hence Linnaeus very rightly gave the bark name cinchona. So cinchona is a bark of many species of plants belonging to genus Cinchona. To name a few: Cinchona calisaya, Cinchona legeriana, Cinchona officinalis, or Cinchona saxirubra. Now in some cases what happens is, if you take the first two and then hybridize it with the next two, that is officinalis and saxirubra, you get few more Cinchona plant species, and those are also being cultivated over. So geographically they occur extensively throughout the world. They occur in Andes, Bolivia, Peru. You will see them cultivated in Indonesia, Colombia, in India. We even have a quinine production plant, Guatemala, Bolivia, Ceylon. So this cinchona barks occur as quills, that is they are dried and curved as quills or double quills. So this is a very tiny seed, less than a half centimeter. This is propagated mostly by sowing. Now this initial stages, the seedlings are well protected from sunlight till they attain a height of about 25 centimeters. Now once the seedling grows, it has been transplanted at least twice. These plants, when they are 1.5 years old, they are cultivated into open fields, because once they grow into trees they are going to acquire a huge area. Now taking into account their girth and their growth, a space of 1 meter is kept between each of these seedlings. Now first crop is taken as early as 6 years, and once they get old or more than 9 years old, it is seen that the content of quinine alkaloids especially goes on decreasing. Now we don't want a decreased yield, and definitely after 9 years they are completely uprooted. Now rainy season is thought to be a best season for collection. Mostly sometimes they were collected from old, but now with the cultivation happening, what is done is during the rainy season, when the bark is little soft, they are threshed or beaten to loosen from the periderm region and then pulled out. Now in some cases the plant is uprooted to get the root bark. The difference between the stem bark and root bark is, generally in your market you get your stem bark with sizes as big as 30 centimeter in length, whereas the stem root barks are tiny. The root barks are approximately 5 to 10 centimeters in length. So you can make out by length whether it's a stem bark or a root bark. Now once you subject it to drying, the bark acquires a little curved or what is called as quill shape. It has a tannin, so it acquires a red or reddish brown color. The stem bark also shows presence of fungus, lichens, and those can be also used to identify whether the bark has been obtained from stem or root. Coming to chemical constituents, about 30 alkaloids have been reported in cinchona. It contains compounds such as quinine, quinidine. Now interestingly, if you see, quinine and quinidine structures are very much similar. The difference lies here at the ninth position. So if you see here at the ninth position, the hydroxyl group acquires a R orientation, whereas in this case it's an S orientation. Again, if you go to see the 8th position with respect to hydrogen, you can say this acquires an S position, whereas in quinidine you will get an R position. So that's a little difference, otherwise structurally it's exactly the same. It's just a little isomerism difference. Now this isomerism difference is also responsible for difference in activity. While quinine proves to be a very strong antipyretic and antimalarial agent, quinidine is not as effective. In fact, it has more effects on heart or CVS. Now, if you just see this R group out here, that's the functionality. In quinine and quinidine, it's a methoxy substitution. Remove that and replace it with hydrogen, you get what is called as cinchonidine and cinchonin. Cinchonidine and cinchonin are in the same way are isomers, but missing methoxy as compared to your quinine and quinidine. Apart from that, many other alkaloids are present. This include quininarin, cincotin, hydroquinone, hydrocinchonidine, and this is often found in complexation. Now these are alkaloids, these are basic in nature, so they form association with acids. So two acids are predominantly seen in cinchona bark. One is quinic acid and other is your cinchotanic acid. So these two acids often form complexes with your cinchona alkaloids. Now apart from that, it contains few bitter glycosides, starch grains, calcium oxalate as well. Now it is said that the alkaloids are predominantly located in the parenchymatous part of the bark. Now if I have to check whether the cinchona bark contains these alkaloids, for your alkaloids such as quinine, which are like quinoline type of alkaloids, you can do a simple test called as Thialloquine test. Now what is the Thialloquine test is you extract cinchona powder and in water or in alcohol and add a drop of dilute sulfuric acid and little bit of water or aqueous extract well diluted. To that you can filter it to get the observations more clearly and go on adding drop by drop of bromine water. Now you will see that the solution changes its color, little bit to a more yellowish tinge. Okay, when it changes to that yellowish tinge, you start adding a little bit of alkali, preferably ammonia solution. When adding ammonia solution, approximately when you add a ml of it, you will see an emerald green color. This is a test for quinoline alkaloids. You can also do one more test is you take powder drug and heat it with glacial acetic acid in a dry tube and you will see the red fumes emanating. These fumes condense quickly on the sides of test tube and that becomes more visible. The interesting test what you can see in cinchona is fluorescence test. Now this cinchona bark contains quinine and quinidine, and quinine and quinidine have a ability to fluoresce. What is fluoresce? Fluorescence is an ability of a compound to glow. Now what exactly is glowing? Glowing is basically absorbing a particular wavelength of light and then instead of emitting the same, if I emit it at a little higher wavelength, in that case what I get is a glow or a fluorescence. Now quinine sulfate has an ability to produce fluorescence. So if you see, it absorbs somewhere at 317 to 349 nanometers wavelength and emits somewhere at a higher wavelength It is about 481 nanometers. This is mostly attributed to that methoxy group present which we recently saw. So here what is done in this beaker is we have taken extract, uh, alcoholic extract of cinchona bark, and that alcoholic extract we've just added a drop of sulfuric acid. This is exposed to a UV lamp of about 365 nanometers, and you can see quinine which is present in that produces an intense fluorescence. Now one interesting application of this fluorescence is sometime in your brewery, liquor industry, where people prefer their brew such as beer to be little bitter. In that case, a little bit of quinine is added. Now quinine is very much bitter, so very dilute solution is added. So if you take your glass of liquor or beer and keep it under UV lamp, and if you get this kind of fluorescence, there is a good chance that quinine has been added, especially quinine sulfate has been added to increase the flavor or bitterness of the alcoholic drink. So application, the first and foremost application is anti-malarial because it has the ability to kill Plasmodium, especially Plasmodium falciparum, which is the main parasite responsible for malaria. Apart from that, it has analgesic, antipyretic, it kills microorganisms due to its protoplasmic effect. It is intensively bitter and hence considered as bitter stomachic and tonic. Now quinidine, which we saw is an isomer of quinine, like I said, apart from its structure, it gives an entirely different set of activities that is on the CVS. So quinidine is a cardiac depressant, and cinchonidine, if you go to see, is mostly used in rheumatism and neuralgia. Quinine hydrochloride is very bitter and has a bitterness value close to 2 lakh. Now what does that mean, a bitterness value of 2 lakh? If I take a gram of quinine and dilute it 2 lakh times, still I'll be able to perceive the bitterness of quinine in that particular solution. So imagine even this dilute solution of quinine can be bitter, and hence in different methods of evaluation, quinine sulfate is often used as a bitterness standard. Now moving on to the next drug, our next drug is a xerophytic drug called as ephedra. It grows in the Himalayan belts and mostly in the Chinese region, and it's synonymously called as mahuang. Now ephedra is the dried aerial parts, predominantly the stem. Because this is a xerophytic adaptation, so the stems acquire green color, they have chlorophyll, and the leaves are barely present in sets of 2, in some cases 3 or 4, but very rarely at the nodes. And it has different species which are used in medicine. If you go to see the Indian perspective, the ephedra from India comes from Ephedra gerardiana and Ephedra major, whereas if you see the Chinese side, you can get mostly ephedra belonging to Ephedra sinica, Ephedra equistina, in some cases Ephedra nevrodensis is also present. All of them belong to the family Ephedraceae. Like I said, it's growing in the Himalayan tracts, so you can see it growing right from China, Nepal, India, Pakistan, Bhutan, Turkey. So this region, this is adapted to very dry, arid and xerophytic conditions. You will see the drug like a thin stems which shows shriveled appearance. Now depending upon the species of ephedra, the thickness of the stems may vary and the distance between the nodes will also vary. Now being a xerophytic shrub, it barely grows about half a meter to 2 meter in height. Mostly it's cultivated in autumn, for the reason being it has a very good content of alkaloids in them, and during the autumn season you will see that the twigs are nice, green and slender. So once the plant or the aerial parts are picked, they are packed loose in bags, and during the packing some of them break and you will see tiny twigs when you see the drug of commerce. Now in terms of chemical constituents, it contains about 0.5 to 2% alkaloids, chiefly belonging to what are called as protoalkaloids. If you see here, there are examples of phenylethylamines that we discussed last time. So this is the phenyl, ethyl, that is 1 and 2 for ethyl, amine derivative. So in phenylethylamine we have ephedrine. Now this occurs optically in different forms. So here you have a minus erythroephedrine. Here there's a plus ephedrine or plus erythroephedrine, where you can see both of the substituents hydroxy and methyl here are above the plane, and here if you go to see, both are below the plane. Now pseudoephedrine is a case where one of the functionality is above the plane and one of the functionality is below. So if hydroxy is above, methyl is below, and if methyl is above, hydroxy is below. You call it as pseudoephedrine. So here you have a positive pseudoephedrine with a SS configuration, and here you have a negative pseudoephedrine with an RR configuration. Now nor pseudoephedrine is a derivative of pseudoephedrine in which the methyl group is absent. So you remove this and just replace it by hydrogen. What you're going to get is a nor pseudoephedrine. So apart from that, it also contains other compounds, tannins, saponins, flavones, as well as in some cases little traces of volatile oil. Now being xerophytic, if you carefully do a transverse section, you will see adaptations such as a lot of chlorophyll in the stem and xerophytic, typically sunken stomata. Now to evaluate this drug, we can do a few chemical tests. Take a little drug, boil it in water to create an aqueous extract. To that aqueous extract, just add a drop of dilute hydrochloric acid and a drop of copper sulfate solution. Mix it well and let it heat for some time, and then on cooling you add your sodium hydroxide, about large excess, about 2 ml. You will see that this liquid turns purplish or violet in coloration. Now to this, if you add any organic solvent such as ether and shake vigorously, this purple color is transferred to the ethereal layer and the aqueous side or the aqueous layer becomes little blue. In terms of applications or uses of ephedrine, the advantage is you need not inject it, you can orally consume and still it gives you much desired effects. So it is used as anti-allergic, especially in hay fever. It is used as anti-asthmatic, anti-spasmodic. It is a decongestant, cough suppressant, stimulant, and a vasoconstrictor. So it is also used to treat angina. Pseudoephedrine is also showing almost similar activities as a decongestant, cough suppressant. Nor pseudoephedrine is mostly used as a peripheral vasodilator to treat angina. Now, ephedrine has the ability to stimulate heart rate, increase BP, promote bronchodilation, and exhibits very pronounced effects on the CNS because of its ability to bind with adrenergic effects or adrenergic receptors. Pseudoephedrine has, like I said, similar effects but less CNS effects as compared to ephedrine. Now we move on to the third drug, and the third drug we use in Indian system of medicine is referred to as Adulsa or Vasaka, or also referred to as Malabar nut. Now what we do is we take leaves of this plant, that is Ajustica adhatoda or Adhatoda vasaka. It's a Acanthaceae family member. This plant grows mostly throughout in the tropical belts of Southeast Asia and acquires a good height of 2 to 4 meters. It bears beautiful white to pinkish flowers, and it bears like tiny capsules containing seeds on maturation. Coming to the constituent, it contains quinazoline kind of alkaloids, and the most important one in them is vasicine. Vasicine is the one which is responsible for having the antitussive effect which is given by Adulsa. Now this vasicine on exposure to light gets slowly oxidized and is converted into vacicinone. So you will see plant contains vasicin as well as vacicinone, or even if you purify vaccine over a period of time due to oxidation, it has a good ability to convert into vacicinone, and hence Adulsa syrups you will mostly find it in a amber color bottle to protect it from light. Apart from that, it has flavonoids, terpenes, certain sugars as well as glycosides. Now other alkaloids which are present include vacicinol, adhatonine and adhavacicinone. The flowers, whitish or pinkish in color, are known to contain sitosterol, especially beta sitosterol glycoside, as well as a flavonoid camphorol. Now in terms of applications, Adulsa has been used traditionally for many years in Ayurvedic system of medicine to cure or to treat cough, asthma, fever, in some cases tuberculosis, the extract to treat piles, jaundice or even bleeding gums. It's mostly used as expectorant. It has a good ability to treat cold and rheumatism. Now, it also cures bronchial, asthmatic or pulmonary affection. Apart from that, it is also given in combination with other drugs for its antimicrobial, hepatoprotective and antioxidant activity. It has been used traditionally, but the mechanism is not known clearly to treat leprosy and certain blood disorders. At little larger doses, it has a little sedative effect, but yes, it also shows antispasmodic, anti-inflammatory. It can show anti-diabetic effects. On some research scale, it has been proved. It also has anti-ulcer and it's moderately hypotensive. So thank you everyone for your patient listening. Here are few references if you wish to know more further about this drug. Thank you.